Hello, welcome to our math practice today, and today we are talking about linear inequalities. These are our questions. We have 5 numbers that we need to do. Please try the questions before you look at the answers. Let's continue and look at our first inequality here. And then it says solve the inequality, and then the inequality is here, greater than or equal to this. Whenever we have a question with fractions, you can always first remove the denominators. How? By multiplying through by the LCM. So we have a 4 and a 2 and a 1, so the LCM is a 4. So I'll multiply by 4 straight away. So when I multiply this by 4, I have x. When I multiply this by 4, I have plus 20 is greater than or equal to, multiply by 4, I have 4, multiply by 4 here, this goes into 2, so we have plus 2x. After that, we can put like terms together. I have a 20 here. Let me move this term to this side. Let me move this term to this side so that I write 20 minus 4 is 16 is greater than or equal to 2x. When I bring this to this side, it becomes 2x minus x, which is x. So this is our answer. 16 is greater than or equal to x, which we can also write as x is greater than, x is less than or equal to 16 when we start from this side. At this step, you should have noticed that I decided to move the x term to this side, simply to dodge a certain step. But we can also look at it. If I was to move this to this side, I'd write x minus 2x is greater than or equal to, I have a 4 on this side, then 20 will come to this side, minus 20. So here I'll have minus x is greater than or equal to a negative 16. And so to turn this into positive, I need to divide by a negative 1 on both sides. So whenever we divide by a negative number and we are solving an inequality, the sign must change. So instead of this, I'll change it to less than or equal to. That's what I try to dodge. But you can always do that. Feel free to do that. And even in this, you notice that we have x is less than or equal to 16. So that's question 1. Question 2, solve the inequality. A half minus 2 out of 3x is less than 1 out of 6x minus 4. So still here we shall multiply through by the LCM. It helps us to handle whole parts than the fraction. So when I multiply by 12, let me do that. 12 times a half minus 12 times 2 out of 3x is less than 12 times 1 out of 6 x minus 12 times a quarter. So I multiply 12 by each and every term, 1 and 4, 1 and 2, 1 and 3. Okay, do not just multiply on the two sides. When that is done, so here I can see 6 times 1, 6, then 6 there, minus, now I have a 4 times a 2, 8x is less than, here I have 2x, this is a 3 times 1 minus 3. Put like terms together. Let me take this to this side and then the 6 to this side. So here I have minus 8x. When a term crosses the inequality sign, which is a less than, because it changes sign, it's less than, here we have minus 3. When this 6 crosses the inequality sign, it changes to minus 6. So here we have minus 10x is less than negative 9. So when I see that, I need to divide on both sides by negative 10. Okay, do not forget that we said whenever we divide by a negative number, the sign must be reversed. So from a less than sign, I change it to into a greater than sign. That's the only trick. Otherwise, when you're solving this, it's like the way we handle linear equations. So I have x is greater than 9 out of 10. That's our question 2. Question 3, find the integral values, okay, from integers. Integral values of y in the inequality, and this is our inequality here. A nice one, if y is greater than 9. So here we need to state the values of y, or we can start by solving this. So we have, when you put like terms together, 2y will be less than 27 minus 3. So 2y is less than 24. Divide on both sides by 2 by 2. We have y is less than 12. Okay, that's our solution. But now they have told us to set the integral values of y, and we have a condition here if y is greater than 9. And when we solve the inequality, we are getting that y is less than 12. So that means the values of y, y can take on values. Give me for that. Y can take on values greater than 9 but less than 12, and these values must be integers. That's the meaning here. So the integers here, we have a 10, and 11. So those are the two integral values that are greater than 9 but less than a 12. Okay, that was good 4 marks to enjoy. Question 4 says, using a number line, find the integral values. Again, we are supposed to get the integral values of x which satisfy the sets. Now we are given two sets. We have a set 3x is greater than 2x plus 5, intersection another set 3x is less than 32 minus x. So we can start by simplifying. When we take this to this side, we have 3x minus 2x is greater than 5, so x is greater than 5. That is the part, the other side. Then let us also work out this side, bring this x to this side, 4x, let me just have one step there if I write that. So 3x plus x is less than 32. When this crosses the less than symbol, it becomes positive. So we have 4x is less than 32 divided by 4 on both sides. We do have our x less than 8. Now, when you put these two statements together, the first statement says x is greater than 5, and then the second is saying x is less than 8. So we can combine and write one statement, which will be x is greater than 5, but x is less than 8. So this is the intersection of, this is the statement putting the two together. Now we are interested in showing the intersection on the number line, and this is how we do it. Since all of them are positive numbers, I can start with a 0 somewhere here. I don't need a lot of negative numbers. 0, 1, 2, 3, 4, 5, 6, 7, and 8, 9, 10. On this side I have negative numbers. So x is greater than 5. Okay, and so since x is greater than 5, I'll simply come right at the top of 5. I want to use this, and I draw there a small dot. Okay, and we are going to have this dot unshaded because we are interested in values of x which are greater than 5. Then also I'll get to where I have 8. I draw the small dot. This should be right on top, and I'll also leave this unshaded to show that 8 is not part. Strictly, you'll see that the values of x must be less than 8. And so we can now connect this using a straight line. So this is our intersection here. This is our intersection here. And the integral values in this intersection, the integral values that we have there, the integers are 6 and 7. So in the intersection of the two inequalities, we have there 6 and 7. Okay, and our final question of the day, we have a set A has elements x such that x is greater than or equal to -2 but less than or equal to 1. And another set B is a set with elements x such that x is greater than 0 but less than or equal to 5. That's how we can read that set notation there. We want to represent A intersection B on a number line. We want to represent this intersection on the number line. Now, after reading these two set notations, we want first of all to write A intersection B using set notation. This set will also have elements x such that, now when you look at the first set A, we see that it starts from -2. If I'm to put here elements and I use them to talk about the solution, 0, 1, 2, 3, 4, 5, 6, 7. On this side we have the negatives. This is -1, -2, -3, -4. Now for this first set here, it starts with an integral value -2. But then the second set starts with an integral value 0. So since we're interested in the intersection, okay, anything that is outside, this is where I have the 0, this is where I have the -2. Since in the second set we don't have these integral values here, these elements of x, by the way, in this case we should not assume that they are integers. We have just been told that it is x. We don't know whether it should be only integral values. So elements that are on this side cannot be in the intersection because we don't have them in the second set B. But at least 0 is also in this first set here. So I'll come at this point and I have this. I indicate that this is part of the intersection. I want to use just a dotted line there. Dotted line. And now since 0 is not in the second set, that means even in the intersection it will not be there. So we draw here a small 0 and we are not going to shade it to show that it's not part of the solution. Okay, now let's see the other limits. The first set stops at 1. This set stops at a 5. Okay, and so now since we are interested in their intersection, there is no way we shall move up to 5, but we shall stop at a 1. So we can come right above here. 1 is also there. Okay, and now since 1 is a member in this set A here, and when you look at this set here, it is also there, then it must be included, and we can show that by shading this, by shading here. I'm trying to shade, okay, to show that 1 is part of the intersection. And after that we can draw a line showing that, okay, showing that. And so in our intersection we have 0 but x is greater than 0 by the nature of this, and then it should be less than or equal to 1. So that is our intersection, and it's what we have represented on the number line. Thank you. keep subscribing for more videos.